In this chapter, we will look at data in a more structured form, within an Excel table. Excel tables can be used to make managing and analyzing related data, or data with multiple columns and rows, much easier. Excel tables are powerful themselves, for analysis in spreadsheets. But they also serve as the output, and sometimes for the input, for Power Query. Power Query is a data preparation and transformation tool inside of Excel. We won't spend too much time on this subject, as Beta has entire courses dedicated to the topic. But we will cover a few examples to see how Power Query is the modern replacement for VBA in Excel, achieving some of the same data transformation tasks. We will also look at linked data types, which provide the ability to connect to data on a wide variety of different subjects, directly from within Excel. We'll see how we can use linked data types with Excel tables and also with Power Query to see how we can create and enhance tables of data. By the end of this chapter, we will be ready to use Excel tables as the foundation for a more robust analysis, with Power Query, linked data types, and some other features that we will explore later in the course. Let's get started. Excel tables can be used to make managing and analyzing related data, or data with multiple columns and rows, easier. Here, we have some tabular data in our worksheet. We've used datasets like this in the course so far, but let's convert this data into an Excel table this time. To do this, I can select all of our data, and I can navigate to the ribbon on the Home tab, and then in the Styles section, Format as Table, and then select my style. Alternatively, I can use the keyboard shortcut Ctrl-T. And when I do that, this brings up the Create a Table pane. My table does have headers. These are the names of the columns, and I've already selected the data for the table, so I can select OK. And now that we've created our table, we see that we have an additional tab on the ribbon, Table Design. Let's take a look at a few elements of our Excel table. One of the things we can do is we can rename our Excel table. So right now it has a default table name. Mine's Table 7, yours might be Table 1, but let's rename that to student_grades. If I click into the table in the worksheet, we can see a few benefits of using an Excel table. If I scroll down, we see that the column headers are frozen. They don't disappear once row 1 is not in our current view in our spreadsheet anymore. Within the table headers themselves, we can also filter and sort our data. We can sort alphabetically, and we can also filter, either text filters or from the drop-down menu here. We have banded rows, which make our data easier to read. We have alternating colors in every second row, and that can help us see which information from our columns are related all the way across the row. Another benefit of using an Excel table is the automatic table expansion. When we want to add new information to our table can automatically expand to include that information. If I scroll over to the right, I can select this data, and we can cut it and paste it at the bottom of our table. And when I do that, we see that we have a new row created automatically. And we can see that with the blue background from the banded row. We can also add another column to our data set. I can add year, and then I can type in a formula equals 2022. And our table has resized to include this new information. If I go back to the Table Design tab on the ribbon, one option we have in the Table Styles Options section are total rows. So when I click that, we have an extra row added to our table. And let's go to the Office Hours Participated column. And if I click on the total row at the bottom of that column, from the drop-down, we see we have a few different options of the total that we can include. We can add a sum, and in tutorials attended besides that, we can add average. And then from the drop-down next to that as well, we have other options such as max, min, standard deviation, or even more functions as well. If I click back on the average, we can see that these totals use the subtotal function. This function uses two parameters. We have a numbered argument first, and then we have the column that we want to apply the subtotal to. If we recall, from the dropdown, we selected average, and this 101 is a function number that we see from the IntelliSense underneath. A reference to these function numbers are available online if we want to dig in and find out a little bit more about all of these aggregate functions that we can use with the subtotal function. But for now, we'll leave it there. If I go back to this Table Styles Options section, from the Table Design tab on the ribbon, we have a few different formatting options. If we toggle first column, we can see that the first column is now bold, and the same with last column. Those values are bolded. We can also band our columns as well as our rows, which can make it a little bit easier. Instead of looking horizontally across the table, it can make it easier to see vertically up and down if we have a lot of different columns in our data set. And finally, we have the filter button. As I mentioned earlier, from the drop-down in the column header, we can filter our data using this button, but we can toggle that on and off if we don't want our users to do that. Finally, we can change the appearance of our Excel table in this Table Styles section over here. We have different colors and different styles that we can choose from, and I encourage you to explore this on your own. But now that we've covered how to create and expand a table, along with some of the styling options, let's move on to see how we can use Excel tables to make our analysis more efficient with calculated columns. A key benefit of using Excel tables are the calculated columns. Creating new columns with formulas in Excel tables can make our work more efficient and allow us to more easily see which columns are referenced in our formula. We saw in the last lesson that when we define a formula within an Excel table, even if we just do it in the first row, that formula fills down to fill in all rows in the table. To see this again, let's create a new column. We'll call this tuition increase. And we can set this formula. We're going to reference the tuition column. And we just want to multiply that by 1.1. And we see this formula fills down all the way to the bottom of our table. When we reference the tuition column, within the formula bar, we see that we have square brackets, and we have this @ symbol before the name of our column, the tuition column. And this @ symbol means that we're only referencing this single row of the table for our formula. So when we multiply this row, we're only referencing this value of tuition. And in the next row, we're referencing the next value, and so on. The square brackets indicate that we're making a structured reference to a specific column in our Excel table. If I create a new column called Extra Attendance, I can use Excel functions, some of which that we've seen before, on columns within our Excel table, or even multiple columns in our Excel table. If I want, I can sum the office hours participated and tutorials attended, and hit OK. And we can see in the formula bar once again, we have these structured references, and we're using column specifiers, the office hours participated and tutorials attended. We can also use conditional logic in Excel tables. I can create a new column again called attendance, and I can define a formula. If our classes skipped column is less than 5, then I want to return the value of an award, and if not, I can return a value of no award. And close the bracket, and that fills all the way to the bottom of our table. I can also look up additional data to expand the information in our table as well. Let's create a new column called Department. And if we scroll over to the right, we see that we have some additional information here to add to our table. we want to add this department value. So I can use the VLOOKUP function, and the value that we want to look up is our faculty. And if I scroll back to our lookup table, the table array to choose from is this lookup table. The column index is 2, I want to return the department, and I want an exact match, so the fourth argument will be false. And when I do that, we see that the first few rows work, but then we get NA values further down. And that's because I didn't anchor the reference to this array over here. So if I use F4, once I update our formula with that, it works and we go all the way down to the bottom. We have the correct lookup values. One thing I could do as well, though, is I can convert this array into a table. So I can format table and say that our table has headers and select OK. And let's rename this table to department underscore lookup. And now I can update our formula rather than an anchored reference. I could change this to department lookup. And now I don't need to worry about anchoring any cell references. I can just reference this table. In addition to column specifiers, we also have special item specifiers with our structured references. If I go down to this information under here, next to this data row header, I can type in equals student grades. If I type in an opening square bracket, we can see some of the options available to us. We see references to all of the columns in our table. But if I scroll down to the bottom, we also have these special identifiers, these special items. We have all data, headers, and totals. So if I exit out of this formula for now, let's go and use the rows function, which will count the number of rows in a reference to an array. So let's reference the student grades table, do an opening bracket, and then the hash symbol, and this time let's refer to data. And we see we have 31 rows. And if we scroll back to our table and scroll down, we have 32 rows in our table. But remember that one of those rows is a column header. So we just have 31 rows of actual information within our Excel table. If I want to see how many header rows I have, I can use columns. And once again, I can go to student grades, headers, and I can see that I have 14 headers in our table. I can do the same thing to see how many total rows I have, or if I want to return all the rows in our table, I can use rows, student grades, opening bracket, hash sign, all, close those off, and we have 33, because we have 31 rows of data, plus a headers row, and plus a totals row as well. If I didn't wrap these special item specifiers with the rows function, I would actually create a new array in our workbook. So if I reference student grades, then have the open bracket, let's just look at student ID and close that off and hit OK. We see that we now have an array that spills all the way down and contains all of the student IDs from our student grades table. I can do something similar. I can reference student grades, but this time I can use at this row, this special identifier, along with student ID. Close that off, and now I only return one specific student ID. Remember, I'm using the @ sign, so I only get the student ID for this row in our table. We'll leave it here for now, but we will see more of this spill behavior with arrays a little bit later in the course. With these examples, we've seen that it's easy to add additional columns of data to our Excel tables with the automatic filling down of the formulas, And we also have the ability to reference different items of our Excel table, using both column specifiers as well as special item specifiers. Power Query is a data preparation and transformation tool inside of Excel. Power Query comes with a graphical interface for getting data from sources and applying transformations. Using Power Query, you can perform the extract, transform, and load, or ETL processing, of data. Power Query can connect to a wide range of data sources and apply hundreds of different data transformations by previewing data and selecting transformations with the user interface. These data transformation capabilities are common across all data sources. The Power Query editor allows you to apply and record the transformations you need simply by interacting with a familiar set of tools, the ribbon, menus, buttons, and other interactive components. When you create a new transformation step by interacting with the components of the Power Query interface, Power Query automatically creates the M code required to do the transformation, so you don't need to write any code. Power Query is available as an add-in for Excel 2010 and 2013. From Excel 2016 and onwards, Power Query has become a built-in feature in Excel. If you're using Excel 2016 or newer, you'll find Power Query under the Data tab. It's been renamed to Get and Transform, which also means if you ever see that name online, Get and Transform and Power Query are the same thing. If you can see Get and Transform, or if you have an older version and you can see the Power Query tab, you're all set. Otherwise, you may need to install the add-in. Let's take a closer look at Power Query with a few examples. In this lesson, we will look at two basic data transformation examples with Power Query. We'll use this small data table to be our source data. It has 3 columns, a GL account number, a date, and a GL amount column, which is the amount for a specific account on a specific date. This could potentially come from a different source, like a SQL Server, a different Excel file, or from the web. And it could also be a much larger data set, with more columns and rows. But the transformation steps that we're going to look at would be exactly the same, regardless of the size or the source of the data. For our first example, our goal is to return a new table under the headers here that filters our source table to only return the rows where the GL amount is greater than 3,000. To do this in Power Query, we can click anywhere on the table here, navigate to the Data tab on the ribbon, and then select From Table or Range. And once we do that, that brings us into the Power Query editor. In the center of the Power Query editor, we can see the Data view, and this is a preview of exactly what our data looks like in its current form. And as we make data transformations to our data, we'll see that this view will change. On the right-hand side, we have the Query Settings area, which is going to list out all of the transformations that we make to our data. If we can't see this pane, we can go to the View tab on the ribbon and press the Query Settings button here, which shows and hides this pane. On the left-hand side, we have the Queries list. At the moment, we've only got one query, but as we progress and create different examples, we can have multiple queries listed here. Along the top of the page, within the ribbon, we have lots of different buttons and different tabs on the ribbon, which will help us transform our data in different ways. We'll cover the ribbon in a little bit more detail as we go through our two examples. A first step for transforming our data, we can rename our query. Let's call it Filtered Table. And we can rename the query in the Query Settings pane, or we can double-click on the queries list to the left-hand side. If we look at our applied steps, we have a source step already, and then we've changed the data type. But rather than date time, let's change this date column to be a date type. And to do this, I can click on the icon next to date in the column header, and I can select date from the drop-down. And I want to replace the current step. Now, to filter our GL amount column to only return values greater than 3000, I can hit the drop down from the column header, and under number filters, greater than, and I want to only keep rows where GL amount is greater than 3000. I can enter that in this box and press OK. If we look at the formula bar here, we can see that we've filtered the GL amount column to be greater than 3000. If you can't see the formula bar, you may need to go to the View tab and click on the formula bar toggle box here. And at this point now we're ready to load this back into our worksheet. This is all the data transformation that we need to do, just changing the data types and filtering the rows. To load this back into our worksheet, from the Home tab, we can see this Close and Load button to the left. From the drop-down, I want to select Close and Load To. And then we have a few different options of what we want to do with our data. I want to view this data in our workbook as a table. I want it on an existing worksheet. I want it in cell E2. And I don't want to load this data to the data model. So I'm going to uncheck that box. And then I'm going to press OK. And now we see we have our filtered data table here. It's a subset of our source data, but it only contains GLs that have a value greater than 3000. And now we're ready to move on to our next example. For our next example, we want to return the average GL amount for each of the GL accounts in our source table. So once again, I need to create a query using this source data as our data source. So I'll click on the table, and on the Data tab, rather than the From Table Range button, I can select the drop-down next to Get Data, and this gives us the full options of all the data sources available to us. I'm going to navigate to From Other Sources, and then select From Table or Range from the drop-down. And we have the same starting point as our previous example. Let's rename this query to Aggregated Data. And at this point, I want to group our data. We don't care about the date column. We just want to group our GL accounts and then find the aggregated amount, our average amount. So I can click on the date column, and I can either right-click and select Remove, or I can select the date column, and then from the Home tab on the ribbon, Remove Column, Remove Columns. And we have a new applied step added in our query settings pane on the right. When we interact with the Power Query Editor and select Buttons to do our data manipulation, these steps are automatically added to the query settings on the right. When we click back to the first step, we see that we connect to our data source in the source step, and then we see a change type step. So this is the next data transformation that was applied to our data. We changed the data types of the columns. And then the transformation step that we just did, we removed the date column. Now I want to select the GL account column, and I want to group this data. So from the Home tab on the ribbon, I can select Group By. This option is also available on the Transform tab. I can select the column that we want, our GL account column, and then the very first option over to the left-hand side in the table section, Group By. And this brings up this dialog pane. I want to group by our GL account column, and then I have a few options to fill in. There's the operation, which is the middle box here, and I want to select the average. And I want to select the average of our GL amount column. And we'll name this column Average Amount, and I'll select OK. And now we have a list of GL accounts grouped by the average amount. If we click back to the previous step, we had 10 rows in our data set previously, and once I grouped our data, we now have 8. Finally, we can sort our data by the average amount in descending order. So from the drop-down on our average amount column, we can select Sort Descending. And now our dataset is ordered that way. At this point, I can go to the Home tab on the ribbon. We're done all our data transformation. From the drop-down, from the Close and Load button, I can select Close and Load To. I'm going to select Table from an existing worksheet, and I'll put this in cell I2. And I don't want to load this to the data model, so I'll uncheck that box and select OK. And now we have our second table of data. We've taken the source data, we've grouped the rows, and now we have another table with our GL account numbers and the average amount. Once we manipulate data in Power Query, we can see this Queries and Connections pane pops up on the right, and we see that we have our filtered table example over here to the left, and a preview of the 6 rows loaded, and then our aggregated data query with 8 rows loaded. If we close the Queries and Connections pane, from the Data tab, if we want to bring that back up, we can select Queries and Connections there. If you want to learn more about Power Query and go through some more in-depth examples, make sure to check out BEDA's Power Query Fundamentals course. Linked data types are a special type of data in Excel. They have a connection to an online data source. Instead of using just static information in cells, you can dynamically create information that is related to these data types and is refreshable as this information changes and updates. 2 examples of linked data types in Excel are stocks and geography. Let's review a few examples to see how linked data types work and how we can use them with Power Query to enhance a data model. For our first example here, we have a list of provinces and territories in Canada. If I highlight these cells, I can go to the Data tab on the ribbon and set the data type to Geography. Once I've done that, we can see that within each cell, we have a map icon next to the cell contents. This indicates that this cell has been set to a linked data type of geography. Let's click on this icon. Doing so brings up a card with additional information that relates to this specific province. If we want to add any of this information to our worksheet, we can click on the Extract to Grid icon. I'm going to add the capital city. If we click on this cell and then look at the formula bar, we can see the code that generated this information. Let's copy this formula down. And once I do that, we return the capital city for each of our provinces and territories. Let's name this column Capital City. You may have noticed that the capital city is also recognized as a data type of geography. We can add additional information about the capital city. If I click in cell C2, I can start typing in a formula to retrieve some information for the capital cities. So I'll start with equals B2, which references the linked data type of the capital city. And once I do that, we can see a drop-down list of all available geographic information that pertains to this specific city. So I'm going to add population and hit enter, and then I can drag this formula down. And let's rename this column to capital pop for capital population. To save us from copying the formula down every time, I can select a range of geography data types. So let's go back to our provinces and territories, and I can select an entire range, and then using this insert data icon, I can select what information that I want to insert. So let's scroll down to population, and this time I've inserted the province population. Let's resize our columns so we can see the contents more clearly. What's great about this information that we've generated is that we can use it just like any other data in Excel. So if I wanted to calculate the percent population in the capital city, so percent pop in capital, I could just use a regular Excel formula. I could say capital population divided by province population, and I could copy this formula down. And let's go to the Home tab and set it as a percentage. We've seen how we can quickly generate information that pertains to previously static data within our worksheet. Let's move on to some additional examples. We can pair generating information from a linked data type within a table that we've created using Power Query. Let's look at the linked data type of stocks for this example. Let's start by connecting to some stock information from the web using Power Query. I'll go to the Data tab and get data from web. And then I'm going to paste in a URL that connects to the world indices from Yahoo Finance. And then I'll select OK. Let's connect to the table from the URL and select Transform Data. Let's rename our query to Stocks. And I only want to return the symbol and the name columns. So let's select those two and remove other columns. And then we can filter this data down to just include some of the top indices. And we also need to clean up some of these rows as well. Let's start with the symbol. And we can remove this first character. I'm going to extract data, text after delimiter, and select OK. Let's filter the symbol column. We don't want any blank values. And if we update this applied step, we also don't want to contain any special characters like periods. We'll select OK. Now we can filter the name column. Let's remove any special characters from this name column as well. We'll do text filters, does not contain, and we don't want it to contain a slash, and we also don't want it to contain a period as well. We'll select OK. And now we've cleaned that up a bit, let's just keep the top 5 rows in our table. So we're just going to keep rows, keep top rows, top 5. OK. Let's reorder our columns as well. Let's put our name first, followed by our symbol. OK. Now we can close and load too. Let's close this as a table in our workbook to this existing sheet. We don't need to add it to the data model. OK. Now let's select the data from our symbol column. And then on the Data tab on the ribbon, from Data Types, let's select Stocks. Let's close this Queries and Connections pane. And we see that from rows 3 to 6, or 4 rows from our table, we see that we've recognized the correct index that relates to the symbol. It matches the name column from our table. However, this top row, for the S&P 500, the symbol is not recognized, and we get this data selector option over to the right-hand side. This gives us the ability to manually select data that this symbol should relate to. So let's type in S&P 500 and press search. And now we have a few recommendations. S&P 500 index looks correct to me, so I'll press select. And now we've correctly linked to the right data type. Now we can start adding some additional information for these stocks. So we have the 52-week high, 52-week low, the name of the stock, the open, the previous close, the price. So let's add the price. And we could add some other information as well, like let's add back the ticker symbol. But we've seen how we can use linked data types on top of data that we've connected to in Power Query. We've pulled in data from Power Query from the web, and we've been able to quickly expand on that data with linked data types. So let's move on to our final example. On the previous page, we saw linked data types pair well when using an Excel table. When we add additional information, our table automatically expands, and the formula is copied down for all of the rows in our table. We have the same list of provinces as one of our lessons earlier, but this time it's formatted as an Excel table. So let's add some additional information. Let's select our data and set it as a geography data type. And now we can add the abbreviation, and we can also add the median household income. Another way that we can pair linked data types with Power Query is to use this table as a source for a query. And this is a great option if we want to quickly generate some additional information for a dimension table in our workbook data model. instead of sourcing this information from somewhere else, we can quickly generate this information from inside of Excel. So let's use this table as a data source for a new query. So I'll click anywhere on the table, and then from the Data tab, from Table or Range. So once I create this query, we can see that this first column contains an error for each row. When I click into it, we see that we have a data format error. Let's close the Power Query editor for now and go back into our spreadsheet to investigate. We can discard these changes. Back in the spreadsheet, we see that this first column is what contains the linked data type of geography. One drawback of pairing Power Query with linked data types is that Power Query cannot interpret columns that have been set as linked data types. Fortunately, there is a workaround that we can use. Let's add one additional column of data and add the name column. And now in column D, we've replicated the same content that is contained in column A. Let's create a new query from our table once again. And now when we go to the Power Query editor, we can see the name of our province in column D, even though it's not recognized in column A. So let's remove this first column. I can click on it, right-click, and remove. And we can rename our name column to province/territory. And at this point, we're able to load this query to a table, to the workbook data model, where we could join it to information from other sources, or we could continue with our analysis. So although linked data types are powerful and a useful feature in Excel to quickly connect to data, we need to be aware of the limitations, particularly when connecting it with Power Query. In this chapter, we examined structured data within Excel tables. Excel tables are important to a modern data analysis in Excel, as they can improve the efficiency and robustness of our work. They are also foundational to other aspects of Excel as well, as a data source for features such as Power Query, linked data types, and as we'll see a little bit later, dynamic arrays, pivot tables, and data charts. We are now ready to move on to the next chapter in the course, using dynamic array formulas to analyze our data in Excel. Let's move on with our learning journey.